back. In this chapter, we're going to look at how to understand and compare when we have more than one distribution. In chapter 2, remember that we looked at the association or relationship between two categorical variables, and we did that by looking at contingency tables or displays, right? So we had a lot of displays we could look at. We looked at bar graphs and pie charts and segmented bar graphs and mosaic plots and things like that. So in this chapter, we're going to look at different ways of examining the relationship between variables when one is quantitative. So remember, quantitative variables are variables that are numbers along with their units, and the other indicates groups to compare. So for example, if we wanted to analyze like wind speed patterns during different days, and we wanted to group the days together into different size groups and compare the wind speeds among them, if we partition time in different ways, we can gain flexibility in our analysis. And this comparison will allow us to look at wind speed across months, seasons, over a whole year, and even day by day. So it depends on what you're trying to analyze. Okay. So if you can pause the video right now and read the problem and answer the question. And when you're ready, you can unpause and come back. Consider the histogram, the 5-number summary, and the box plot of average wind speed for every day in 2016. We're asked to describe the distribution. So remember, when you need to describe a distribution, you want to talk about 4 basic things: the shape, the center, the spread, and then of course if there's any outliers or gaps that you see in the data. Okay, so here we would look at this graph and we can see that it's unimodal, it's got one peak, and it's also skewed to the right. The tail is on the right. So that takes care of the shape. Okay, so we would say something like the distribution of average wind speed is unimodal and skewed right. That takes care of the shape. So I want to talk about the center. Okay, so where is this centered about? We can see here that since it's skewed right, we'd want to use the median as our measure of center, and our 5-number summary tells us it was 2.08, and that's miles per hour. So the median wind speed was about 2.08 or 2.1 miles per hour, and since it's the median, that's your 50th percentile, so that means half of the days would have had a wind speed of about 2.1 miles per hour. And then since we're talking about the median, our measure of spread would be the IQR, which is your middle 50%, which remember includes your Q1 to your Q3. So we could say that the wind speed is between 1.4 and 2.9 miles per hour. And then there was a rather windy day, as you can see here, of about 6.17 miles per hour. Okay, so the median daily wind speed is about 2.1 miles per hour. And on half the days, okay, so again, that's your middle 50%. The wind speed is between 1.4, that's your Q1, and 2.9 miles per hour. Okay, that's your Q3, and again, that makes up the IQR. And then it's worth mentioning there was a windy day of about 6.17 miles per hour. Okay, and we can especially see that here in the box plot. So we have our histogram, And we also have our box plot, and we can compare them. So as you can see here, you can tell from the box plot that we have a skewed right distribution. Normally you can't tell shapes from box plots, but you can kind of tell here because there's outliers, which also tells us we'd want to use the median, which we can see here is at about 2 miles per hour. We can also see our IQR here in this box, which is from about 1.4 to 2.9 miles per hour. And we see again our outlier, or at least the value that's far away from the rest of the data, which was 6.17 miles per hour. Okay, so that was looking at the average wind speed for the entire year of 2016. If we take that same data and then we group it according to season, we have fall, spring, summer, and winter. So if you take a look at this, now you can see the wind speeds per season, okay? So what can we determine from this? You can pause the video and then take a look at the graphs and write down what you notice. If you noticed right away, fall, spring, and winter are pretty much similar. Summer really stands out, okay? So what we notice about the summer is we've got our average wind speed along the horizontal axis. There were a lot of days where the wind speed was between 1 and about 1.5 miles per hour, okay? And that's relatively calm. The windiest day was actually in the spring. So if you take a look there, that indicates a windy day of about between 6 and 7 miles per hour. Okay, so here we know that fall, winter, and spring had similar average wind speeds. Summer had a lot of days between 1 and 1.5 miles per hour. Okay, again, that's calm. The windiest day was in the spring. Okay, and it showed that the average wind speed was a little over 6 miles per hour. Okay, so we already answered that question. What do we notice about the distributions? Here's another problem. I would like you to pause the video and unpause it after you've had a chance to read and answer it. The Nest Egg Index devised by the investment firm A.G. Edwards is a measure of saving and investment performance for each of the 50 states based on 12 economic factors, including participation in retirement savings plans, personal debt levels, and home ownership. The average index is 100, and the numbers indicate the percentage above or below the average. There are only 50 values, so a back-to-back stem and leaf plot is an effective display. Here's one comparing the Nest Egg Index in the Northeast and Midwest states to those in the South and the West. In this display, the steps run down the middle of the plot, with the leaves for the two regions to the left or right. So be careful when you read the values on the left. If I'm looking at 5 and then 8, so here and here, that actually represents a Nest Index of 85%. So this would be 85, 87, 87, 88. This is 91, 92, 93, and so on. How do the nest egg indices compare for these regions? So if we take a look at our south and west side, right, and we look at our stem and leaf plot, it's kind of symmetric. I can fold, and it's pretty much the same on the left and the right sides, or the upper and the lower, okay? If you were to take this, the south and west, and I was to turn it, so let me do this. Okay, if I turn this now, you can see how this would resemble a histogram. I'm going to do the same thing for the North and Midwest. Okay, and again, I'm going to turn it. And you can see here how it's also a histogram. So it's kind of easier to read the shapes. So again, you can compare the shapes of the graph. We said this is symmetric. Okay, beware that this is going in opposite order though. So it's going from the 80s to the hundreds. Here, we're going in the correct order from lowest 80s to the hundreds highest. So the shape of the Northeast and Midwest is not symmetric. I can't fold, and it's not the same approximately on both sides. This is more skewed to the left, okay? It kind of trails off on the left sides. So we can say something like, when we're comparing the shapes, the distribution of nest egg indices is nearly symmetric for the south and west regions. And I'm just going to abbreviate S for south, W for west. But we said it was skewed right for the North and Midwest. And Midwest, I'll just call it MW. Okay, so we compared the shapes. What's the next thing I want to compare? I want to compare the spread, and I want to compare the centers. So if we take a look at the south and west, we can see that it ranges from 85 all the way up to about 106. Okay, and then we can see that the Northeast and Midwest goes from 88 all the way up to 114, okay? So the indices were higher and more variable in the North and West, right? They're much higher than in the South and West. If we also take a look here and look at the North and Midwest states, they had higher indices than any states in the Southwest, right? So that's something to note there. So let's put the indices were higher, and let's also say more variable. In the North and Midwest. Than in the Southwest. Okay. 9 northern Midwestern states had higher indices than any states in the Southwest. So what we're talking about there would be the highest here is 106. Here we've got 107, 109, 111, 12, and 14. Okay, so what's the big picture here? When looking at this, would you say that one region is more prepared for retirement than the other? And if so, what would that be? If you answered the Northeast and Midwest, you would be correct. They tend to be a little bit better prepared for retirement than people in the South and the West. And you can see that because they have slightly higher values, right? So let's put here the big picture is people in the Northeast and Midwest tend to be better prepared for retirement than are people in the South and West. That's the end of this video. Please stay tuned for part 2 of comparing distributions.